day 6 of Unit 8 on graphing quadratic functions. Your homework last night for day 5, transforming quadratic functions. Number 9, you had to put them in order from widest to narrowest. Okay, so that one actually gave you the graph, so even without recognizing that 1/4 makes it narrower, and 1/4 is wider, and 4 would be narrower. So they gave you what you're looking at, and remember, positive and negative doesn't matter, they're just looking for the absolute value of the coefficient of x squared. Okay, so as the coefficient gets bigger, the narrower your graph gets. Okay, so now same thing for number 10, what I saw most of you doing in class where you were putting all of these in your calculator to compare them. Perfect. Okay, that's a great strategy. And this obviously is a shortcut. Just to notice, the bigger the coefficient, and remember that coefficient, it's the absolute value. The negative does not matter, the negative just flips it. Okay, reflects it. Alright, 11 through 13 were all translations. Remember, if you are adding on the outside of the x squared, you're moving it up or down. Okay, so 11 was shifted up 3 units, while 12 was shifted down 3 units. Okay, now this one, the reason I gave you this, it seemed like kind of redundant, all the questions I was giving you, but the reason I gave you this is for, to kind of see another way they might word it. So if you're mapping, you're basically going from this function to this function. So they're telling you, how would I go from f of x to g of x? Answer that one. Then they're saying, okay, now go back to f of x. How would I go from f of x to h of x? Okay, that's just to show you that they don't want you to go from here and then from here to here. That's not what they want. Okay, they want you to always start at f of x for this question. Okay, so another thing I wanted to include was, so if we have, let's say f of x is equal to, this is a general form, okay, so x minus h plus k. Okay, so this either goes narrower or wider. All right. The h, okay, so whatever's being subtracted or added to the x moves it left or right. And then on the outside, it would be up or down. Okay, and then remember, a negative a reflects over the x-axis. Okay, so just some general statements for you guys to have when you have an equation like this. It's just easier to look at it like that. Okay, so for today's lesson, we are going to talk about solving quadratic linear systems. So remember, a quadratic is a parabola, and a linear is a line. So when we're talking about solving for a system, remember, we're looking for where they intersect. Okay, we're looking for that intersection point. All right, so go ahead and graph each of those, and then you're going to put both of them on a graph. Okay, on that same coordinate plane. So, of course, I've already done this. Okay, so if you look, when I graph these, I see that both of them share, so obviously I'd put them on the graph, right? So I see they intersect right here and right here. I also see, okay, well at 2, -2, this one's also 2, -2. And then another one they share in common is 5, 1 and 5, 1. Okay, so these are the two solutions. Now, to make sure that they did work, so that you did actually graph them correctly, you also have a little spot to check. So we do have 2 solutions, so you're going to have to do your check twice. Alright, so for the first one, I substituted in 2, negative 2. So remember, everywhere I see an x, and everywhere I see a y. So that's this one. And then for 5, 1, that's what I put into here. So again, all I did was I put a 1 in for my y, and then a 5 in for my x. I checked on both sides, and they did both equal each other. So they, again, you have two solutions, so you have to do two sets of checks. You don't have to, remember, unless it does specify that you do have to check, which it did in these directions. But remember, it's a really quick, easy thing that you can do, so why not? So to kind of generalize this whole entire section, we have a quadratic linear system is always going to be a parabola with a line. So you have, so the nice thing about this, if you get this as a multiple choice question, one of them has to be completely wrong, because you can only have 2, 1, or 0 intersection points. Remember, this is exactly the same as any other system. Whenever a question asks you to solve for the system, regardless of what the two types of, it might be linear and linear, it might be absolute value and linear, quadratic, and it doesn't matter. Whenever they ask you to solve a system, they're asking you where do those points, where do those graphs intersect each other. That's all you're looking for. Okay. So again, we have our two equations. Notice that this one is a quadratic. So f of x is a quadratic, and g of x is linear. Okay, so we're going to have a line and a parabola. And when they say okay, I'll explain this in a minute. Okay, so go ahead and graph those. And yes, I did already do that. Okay, so now as you can see, we only have one intersection point. 0, 1 and 0, 1. Okay. So to answer the, sorry I said that's super weird. To answer the second question, so it says using the graph, determine and state all values of x. Okay, the reason I'm going over this, they ask you this question, and I really need to make sure that you understand. They're not asking you for the coordinate. They want all values of x. Okay, so you take your solution and you just look at the x value. So when f of x is equal to g of x, that happens when x is equal to 0. Okay, so you got to make sure that you're reading the question correctly. That's a way they might ask you. So yes, it's all great. You have your solution drawn on your coordinate plane, but you really got to make sure that you're answering the question that they are asking, or I am asking. Okay, so those two were pretty simple. I gave you number 3 because, remember, if you do not have, these are not solved for y, so we have to solve them for y. Okay, so right here, so I have x squared minus 4x equals 2 plus y. So I'm going to subtract 2 from both sides. So I get x squared minus 4x minus 2 equals y. So there's my first one, and then x plus 2, or y plus 2 equals x. So subtract that 2 And remember, you always like it in y equals mx plus b form. For the quadratic, you want to keep that in standard form. Now, if you wanted to rewrite this, just to make it, look a little nicer, you can absolutely do that. And then again, throw those into your calculator and graph. So if we do that, here's what we get. Okay, now I can't tell you how far down to go with your coordinates. For this one, you really have to look around. Remember, for your parabola, you're always going to want that vertex, all right, just to see the curve, and then make sure for the rest of it, so we want to see those solutions. Okay, we want to see those. So we have two solutions. And you can clearly see those right on the graph. Now, again, remember, label. Let's see. Sorry, I didn't label this one. X plus 2 equals. Okay, so again, where they intersect is what we want. And then make sure you answer the question. Now this one wanted all the values. So for that one, doesn't say x values, just said values. So for that one, you can just write the coordinates. Again, make sure you are understanding or reading carefully what they're actually asking for. All right, questions 4 and 5. Again, we have a of x and we have b of x. It's really no different. Okay, we have a quadratic and we have a linear equation. Throw those into your calculator. And plot them. Okay, so for here, for my quadratic, and again, make sure you have some really nice points. Notice that the vertex, we would have to approximate that, but we don't care about that really. So we have these 2 points. Just be very, very specific when you are putting these down, and make sure that you can clearly see those intersection points. Okay, so we can see that at -2, 0, they intersect, and at -2, 4. Okay. And for the last one, for number 5, okay, make sure that you put this in y equals mx plus b, so we actually have -2x plus 5. Okay, so here's our quadratic, here's our line, and again, there is our answer. All right, and your homework is going to be the last page of the packet. Ooh, homework pages 25 and 26. All right, again, remember, make sure that you are reading. Let's go over just a few things to highlight. Okay, this one asks you for all values of x. So you find your point where they intersect, and then, so x equals what? Okay, so tell me what x equals. For this one, I want the coordinates. Okay, so you're going to give me coordinates where they intersect. Okay, 3, state all values. So I want a coordinate. All right. You can skip this one. Okay. We're not going to do algebraically. You're welcome. So again, homework, pages it's 25 to 26, just numbers 1 through 3.